Dear students, good evening. Myself, Dr. T. Dravidamani, professor, belongs to Safety and Fire Engineering Department. So, as far as our syllabus is concerned, lean manufacturing. So, here number of calculations. That is means as far as industry is concerned, that is cycle time, talk time, and what are the effective utilization time. All those things are recorded in lean manufacturing concept. So let us move to the so that how to calculate all those things. All the calculations are how to calculate. So let us move to the presentations. So first and foremost is cycle time. So how to calculate the cycle time. So what are the formulas required for cycle time? So cycle time, what is the definition of cycle time? The period required to complete one cycle of an operations or to complete a function, job or task from a start to finish. Cycle time is used in differentiating total duration of a process from its run time. So this is a basic definition of cycle time. How to, as per lean manufacturing, how to talk time formula, how to talk time calculated. So the talk time means productive time available per period divided by number of required units per period. So for example, productive time available calculation. So the time available per shift, that means 8 hours. So the 480 minutes. Break 2 at 10 minutes each. So 20 minutes. Lunch 20 minutes. So the productive time available 440 minutes or 26,400 seconds. So talk time, so the production time available per period, number of required units per period. For example, number of required units calculation. So units 72,000 units ordered per month. So how many number of required units? So available time is 60 shifts per month. So divided by 72,000 units divided by 60 per month, 60 shifts per month. So equally 1,200 units required per shift. So here productive time available per period divided by number of required units per period. So for talk time calculation, so talk time equal to, there is a effective production time available is 26,400 seconds available per shift divided by 1,200 units required per shift. So equal to 22 seconds per unit. So the line should make 1 unit every 20 seconds to meet the customer demands. So this is a simple formula for calculating this talk time. So another one is number of operators required. So how much operators required for completing this operation. So the simple formula is sum of manual cycle time divided by talk time. For example, operators required calculation. So 123 seconds divided by 22 seconds is equal to 5.59. So approximately 6 operators required for this completing these operations. So another one is labor efficiency calculations. So the formula is sum of manual cycle time divided by 3,600 seconds per hour multiplied by demand per shift divided by current manning into available hours per shift into 100. Because of efficiency calculation, so final answer into 100. For examples, variables, total manual time to make 1 unit 123 seconds, demand per shift 1,200 units, current manning 7 direct operators, available hours per shift 7.3 hours. So here now labor efficiency equal to sum of the manual time divided by 3,060 seconds per hour in demand per shift divided by current manning into available hours per shift. So the 123 seconds divided by 3,060 seconds multiplied by 1,200 units per shift divided by 7 operators into 7.3 hours per shift into 100. So approximately, so nearly 70% of labor efficiency. So another formula is line capacity calculations. So this is simple formula, the productive time available divided by bottleneck station cycle time. So for example, 26,400 seconds per shift divided by 17 seconds cycle time bottleneck station, that is equal to 1,553 units capacity per shift. This is line capacity per shift. So another performance to capacity, this actual line output divided by line capacity into 100. For example, 1,200 units per shift divided by 1,553 units per shift into 100. So the performance capacity is 77%. So operational availability, how much that is a production operation availability, the simple formula actual outputs divided by demand into 100. So for example, 1080 units per shift divided by 1200 units per shift into 100, so 90%. There is a under production, so overproduction means there is a 1450 units per shift, 1200 units per shift into 100, so 120%. This is the overproduction. So rate of operation. So rate of operation formula. So demand phase capacity in 100. So 1200 units per shift is the demand. 1550 units per shift into 100 is equal to 77%. So this is the rate of operation is 77%. So these are the basic formula is find out how to find out the all the parameters of production area. So all the formulas by applying all the data, so we can easily find out the value of cycle time and operator talk time and productive time, that is the number of operators required, labor efficiency, line capacity, performance to capacity, there is operation availability, rate of operations. So all those things are very essential for lean manufacturing. So in lean manufacturing, this innovative concept mainly focused on elimination of waste. So all the parameters are very essential for finding the what are the waste, what are the underutilization of in the process line. So with this I conclude this chapter. Remaining will be see in the next class. Thank you very much.